Have you ever made an important decision based on a prediction, only to wonder if that prediction was truly reliable and accurate? Predictive model validation is the critical process of rigorously evaluating a predictive model to ensure its accuracy, reliability, and suitability for its intended purpose. It confirms that your model can consistently make sound forecasts, which is vital for effective supply chain planning and optimization, preventing costly errors or missed opportunities. The necessity for validation stems from several core principles of data science and statistical modeling. First, a model is always an abstraction of reality, built upon historical data, and historical patterns do not always perfectly predict future outcomes. Without validation, a model might suffer from what we call overfitting, meaning it performs exceptionally well on the data it was trained on but fails dramatically when presented with new, unseen data. Conversely, an underfit model might be too simplistic, failing to capture the true underlying patterns in your data. Validation helps assess its robustness across different data sets, ensuring that its performance is generalizable and not just a fluke of the training process. It also involves carefully selecting appropriate metrics, such as mean absolute error or root, mean squared error for continuous predictions, or precision and recall for classification tasks, depending on the specific business problem the model addresses. To effectively validate a model, you typically divide your available data into distinct sets: a training set to build the model, a validation set for hyperparameter tuning and preliminary performance checks, and a completely separate test set for the final, unbiased evaluation of the model's performance. This clear separation ensures that your model is genuinely capable of handling new data, mimicking how it will perform in a real-world operational environment. Another common technique is cross-validation, where the data is repeatedly partitioned into training and validation sets to provide a more stable estimate of performance. Understanding and implementing rigorous predictive model validation transforms your supply chain analytics from mere speculation into a reliable strategic asset. It ensures that the insights you derive from your models are trustworthy, enabling more confident decision-making, from demand forecasting and inventory management to logistics optimization. This process empowers you to build resilient supply chains that can confidently anticipate and adapt to future challenges, ultimately leading to greater efficiency, reduced risk, and enhanced operational performance across your entire network.